So good afternoon, everyone. It's a great pleasure to connect with all of you. And we have certainly a great event planned for today. We have our namesake, John Swanson, that's going to talk to us about the inevitable transition to electric vehicles. It's a great treat. What I should also say is that we've done a number of these events lately since we've been in this virtual format, connecting with our alumni, connecting with our constituents and stakeholders. And this one definitely sets the record. If my numbers are correct, Carrie and Kate, I do believe we have more than 400 registrants signed up, which I think is a testament to certainly the connection with John Swanson and also the topic of electric vehicles and why this is so important for the engineering community as one of our most important technology challenges for the development of clean energy sources. Certainly, I want to recognize that we do have some of our trustees present. And I do believe also initially Chancellor Gallagher was going to join. I don't know if he was able to join, but I wanted to recognize that he did sign up. I think he was going to join. I don't see where he's on the call. But we also have two trustee members, Board of Trustee members for the University of Pittsburgh. Ravi Luxbacher should be on, and Bob Akbade. Like to recognize them. And we also have some special guests, Lynn Barenfield, Mary Zeiss, John and Melissa Gorgani, Dave Tannenbaum, Ed Nemeth, Dave Kitch, and Al Beeler, who introduced themselves just a few minutes ago. So welcome to all of you special guests. And again, the focus of today is our namesake, John Swanson, class of 1966 with a PhD in applied mechanics while he was here in Pittsburgh working for Westinghouse. And as I said, these events that we've had during this pandemic has really shown us the thirst to connect as a community, the thirst for events like this, the thirst for us to be connected not only as engineers, but as people and humans, especially in the community of the University of Pittsburgh. So we're certainly fortunate that we're able to reach out and use this technology to connect with so many of you. And for so many of you that are able to attend, because logistically, it's a little more efficient for you to attend this way. So we certainly have appreciated that. And I'd also like to highlight the fact that this is a special year for us as we're emerging from the crisis of COVID-19. 2021 is a year of significance for the Swanson School of Engineering. This marks the 175th year of engineering at the University of Pittsburgh. We're one of the oldest engineering programs in the country, certainly associated with the industrial age and industrialism occurring in Pittsburgh. So we have a strong foundation as an engineering program. It's also the 100th anniversary of our industrial engineering department. I think that's the second oldest industrial engineering department in the world. It's also the 100th anniversary of our student chapter of the American Society of Civil Engineers. Our oldest area of engineering, discipline of engineering is civil engineering. So our student chapter turns 100 years old this year. And it's the 50th anniversary of our home base, Benedum Hall. And so those are all the stars aligning. And if things go the right way, and we're able to meet in person later in the fall, it would certainly be great to be able to celebrate these things together physically. And I think it's fair to say that many of the accomplishments over the last decade or so, the reimagination of Benedum Hall, the new program initiatives, all the student and faculty fellowships, scholarships, professorships, those would not have been possible without the generosity of John Swanson and the vision of John Swanson. His beneficence has given us a lot more than a name. He's really given us a connection to someone who's truly a pioneer in the field of engineering. And he's certainly been a mentor to all of us. And he's he really has done all of this. He's one of the most accomplished engineers in this country, and certainly recognized that way. But he does it with an incredible sense of humility. It's not uncommon when we were able to meet in person to find him downstairs hanging out in Einstein's Bagels or hanging out with students, just walking around the building. And he makes clear every time he comes up here, the number one priority for him is to hang out with our students. And what a treat for them to be able to sit down and talk with John. And that really is the lifeblood of our program, our students. He's had an incredible story, his life story. Most of us know of his work with ANSYS and the founding of ANSYS, which has changed simulation in the field of engineering. In 1970, he founded that. But what most of us might not be familiar with was the fact that he was working with Westinghouse, actually, while he was doing his PhD here in the early 60s and mid 60s. He was working with Westinghouse in the astronuclear division of Westinghouse. And he was looking at doing analysis for a nuclear powered rocket. And he had to develop simulation softwares to calculate the transient stresses and strains on the nuclear reaction system. Nuclear rockets, the way they work with their propulsion systems, they're much more efficient than traditional chemical rockets. And so that was the approach that was being looked at in the early 60s by Westinghouse, is design one of these, get it certified, and use it for space travel. And that project was scrapped in the mid 70s. I think it was 73 by the Nixon administration. And it was during that time that he was developing three-dimensional software that he understood, that he wrote himself, and understood the need for a comprehensive suite of software that can be closely integrated. And he did that. And that's what led to the founding of ANSYS. And I should say that that rocket program, the nuclear energy rocket program, the NERVA program, I think it was called, that is being revisited. And right now, NASA is looking at that technology as a much more efficient way for space travel, as we will look at human space flight to Mars. But I should say, throughout all of his accomplishments and what he's done to revolutionize the field of engineering through simulation, his development of ANSYS, he certainly has been recognized with some of the highest accolades. And in 2004, he was recognized with the John Fritz Medal. And from those of you that might not know, the John Fritz Medal is essentially the Nobel Prize of Engineering. And I think it's every bit as prestigious as the Nobel Prize. Actually, the Nobel Prize was first awarded in 1901, and the John Fritz Medal was first awarded in 1902. And it's for basically the Nobel Prize of Engineering for contributions to the engineering profession. And certainly those of us in the field of engineering, that's what we aspire to. So he was recognized with that. He was also recognized with membership in the National Academy of Engineering. I think that was the class of 2009. And certainly all of that work we're familiar with. Inevitably, here recently, he has turned his attention and focus to the development of clean energy, especially renewable resources, such as solar energy technology. He certainly made a significant amount of contributions for solar panels and some of the work here at Benedum Hall in the areas. We have solar arrays on the roof. We have solar arrays down in our Energy Innovation Center down at the Lower Hill that John has worked on and donated. John has converted his house to renewable energy sources, to harness renewable energy sources, not only at his home, but for several locations there in Florida. And so he has been a champion of renewable energy. And again, it was inevitable that he would turn his attention to electric vehicles. And just to give us a little bit of perspective, the first electric vehicle in this country was developed in, I think it was 1891, somewhere in that range. Not 1991, 1891 in Iowa. That was the first time we had an electric vehicle. It was the predecessor of the modern day SUV. But it was only more than 100 years later that we were able to see development of the battery technology, the materials technology, the capacity with the batteries, and the demand for clean energy that we've seen electric vehicles starting to be more viable as a means of transportation. And so I think it was 25 years ago when the Toyota hybrid, the Prius, the Toyota Prius debuted. And now we see since that time, just over the last 20 or 25 years, Tesla, for instance, is a common sighting around most places. We hear about Tesla all the time. And in fact, if we look at their capitalization, the market value of Tesla is more than most of the big three automakers in this country combined. And who would have thought that? And that transition just occurred here recently. So it certainly is a treat to hear John Swanson give his perspective and his credence to this inevitable shift to our transition to electric vehicles. And so with that, we're excited to welcome John Swanson, and please with me, warmly welcome John Swanson to talk about that with us today. John, we're delighted to have you.
Thank you, Jimmy. It always embarrasses me when the introduction is longer than the talk, but so be it. If I can bring my presentation up here, we'll be in good shape, and away we go. All right, this is going to be a diverse talk because there's a lot of issues that are present in this area, and I want to make sure we all have a common foundation. So we'll start out very lightly and we'll dig into more issues as we go through. So with that, I appreciate everyone being here. I hope everything is working and stays working, and away we go. This is a Zoom presentation. There's a large audience possibly. Everybody should be muted. I think that'll be fine. We are recording, and the copies of the PowerPoint and the Excel worksheet will be available to anyone who wants the same. I have an outline, which is always good. I won't go through it in detail because we'll see it as we go. Now, why an electric vehicle? First of all, they're really great. They're smooth and quiet. There's no transmission. You got high torque at low speed. For example, I'll reference the Tesla Insane mode, where everything it's got is put into the wheels, and it's a 2.5 second, I believe, 0 to 60. Hold your hat. Also, they're very smooth riding, no engine vibration. They're quiet, perhaps too quiet, because some places we have artificial noise generators in the car just to warn the pedestrians that we're creeping up on them. And also they're great handling because of the low center of gravity. And that's a positive and a negative because they have heavy batteries, and we'll get the heavy batteries in a moment. They are low maintenance because the powertrain is much, much simpler than it is for a gasoline powered engines. And of course, last but not least, there's no emissions. So that's the format. This is where I was with why an electric vehicle. And the bottom line, of course, is the driving force behind this. If we didn't have the carbon emissions problem, we probably wouldn't be looking at electric vehicles because there's enough carbon under the United States to last us for many, many years. Now, of course, the comment from MIT Technology Review, for example, this current month, for many buyers, they're simply too expensive, their range is too limited, and charging them isn't nearly as quick and convenient as refueling at the pump. So this is the headwind. They are not quite what we'd like them to be. Going into a little history, this is a Ford Fusion hybrid. This is a hybrid whose only function is to increase the range of the gas engine. You did not put electricity in this from the outside. It was all generated with gasoline. the mileage was typically about 42 miles per gallon, even with the regenerative effect of the electric vehicle. So it has small battery, regenerative braking, downhill energy storage, long total range because it got over 500 miles on the gasoline tank. No range anxieties because of the gas engine. There was some fairly nice logic as to how the battery and the engine work together. I won't go into that because it's past history. The next level is, this is my current car. This is a Toyota Prius Prime 2019. Now, the Ford Fusion I had for about 9 years. Battery was fine, didn't have to change the battery, but it had a mileage capability in that small battery of approximately 1 mile. This has a significantly larger battery. Notice that it's about a $33,000 car. This car I chose deliberately because I wanted to work with a plug-in hybrid. This is the only car of its type that was available not only in the state of Florida, but the entire Southern District of Toyota. So the push behind these cars from Toyota seemed to be almost non-existent. But what have I got? It's larger than the hybrid battery. They claim it has a range of 24 miles. My experience is I get 35 to 36 miles on a charge. But more importantly, it is a small, highly efficient gas engine. If I'm just running on gas at 75 miles an hour, I get 52 miles a gallon. Not at all bad. So it gives me a total range of 500 miles for the gas, plus another 35 miles for the electric, or as they quote in the advertising, total range, about 540 miles. No range anxiety because gas is readily available. And I generally charge the battery overnight by plugging it in when I get home, and it's fully charged in the morning. To be more precise, I set it so that it charges at 8 o'clock in the morning because the solar panels, which Jimmy referred to on my roof, are not running my air conditioning or my heating at that hour, so I can dump directly from the solar panels into the car. It's a little cheaper to use it myself than to sell it to the utility. So basically cost per mile is 2 cents in electric mode, 6 cents in gasoline mode at $3 a gallon and at 12 cents per kilowatt hour. Currently, I have 12,000 plus miles on the car. I've had it 2 years. I have used 29.5 gallons of gas. My net gas mileage on the car is 416 miles per gallon, which I consider fairly green. And if everybody was doing that, we probably make a big step toward getting rid of the carbon issue. However, all the buzz is, of course, oh no, let me show this. This is my dashboard display. A couple points of interest. One, the air conditioning is a significant effect. You can get up to 15 to 20% of your energy usage just running your air conditioning. Also notice that my gas tank is almost full, and it has remained that way ever since the COVID struck. Now, of course, there's the Tesla. This is one of 3 models that are on the road now. Notice the price is a little bit higher. I'll show prices for the other models later in the presentation. I could not justify buying such a vehicle at the present time. I'm glad I didn't. This vehicle gets 3 or 4 miles per kilowatt hour. These are important numbers to remember, miles per kilowatt hour. That's what was on the dashboard display I just showed. That costs about 3 cents per mile if you charge it at home. The mileage goes down as the vehicle size goes up, of course, and the battery is large enough to be used exclusively. And in fact, it must be used exclusively because there is no other option. If you're out of battery, you stop. So therefore, you must find a charging station for a longer trip. Now, longer trip is somewhere around 300 miles. My standard trip, if I'm doing a long trip, is 500 miles per day. That implies I have to charge once in the middle of the day and once at the end of the day. And I personally find that somewhat of a pain. So I don't do it. All right, shifting gears, second item on the agenda, chargers. Chargers come in 3 flavors. The level 1 charger is very simple. You take the cord from the car and plug it into the 120 volt outlet. What do you get? 15 amps, 120 volts, 1.8 kilowatts per hour, and that's a 9-mile range for every hour. Now, that's not very much until you realize that overnight you've got 10 hours. That's a 90-mile range, and the most I can get is about 36. So I could do quite well by just plugging into a 120 volt outlet. No rewiring. This is adequate for the current PHEV, plug-in hybrid electric vehicle. The maximum battery size is approaching 50 miles at this point, as we'll see from a table later on. And these outlets are ubiquitous. You know, any garage is going to have an outlet. So you're all ready to go as soon as you bring the vehicle home. However, you can go a little higher if you want to or feel you need to. Level 2 chargers. This is the bulk of it. This requires a 220 volt, 40 amp outlet, which is similar to an electric dryer outlet. The lower level car, mine's a 2A. I can only draw 15 amps out of this because that's the way the Toyota is set up. However, that gives me 18-mile range per charging hour, which means it needs a maximum of 2 hours. Or for a 10-hour period, I can get 180 miles, but of course I can't because my battery won't support that. It costs about $400 for the charger and maybe $500 installation costs, unless you're a do-it-yourselfer like I am, and I just put it in an afternoon, running it from the breaker box out to where the car is. However, the level 2 has an upper level as well. This draws the full 40 amps at 240 volts. That gives you 9.5 kilowatts per hour or 47.5 mile range each hour. So if I left it plugged in the full 10-hour nighttime, I could get 475 miles out of my level 2 charger, which is more than any battery available on the market. And this is slightly more expensive, but not much. I added another $100 for installation just because it's a bigger breaker. And that's pretty much it. We'll talk a lot about level 2 charging because this is where I think we can successfully do this market. Of course, being an engineer, I have to measure things. And so I measured the level 1 and level 2A charging rates. The horizontal lines are the current. And notice that they are flat. That means there's no peak at the beginning and a very little drop off at the end. So if you plug in one of these vehicles, it's going to charge at its maximum rate for the entire time it's plugged in until the battery is full. You can also see the benefit of the 2A, which are the shorter lines, versus the level 1, which are the 5-hour charging times. I don't need it, except I want to use my solar panels for just an hour or 2 in the morning, as opposed to running all night. We do not have time of day pricing for electricity in Florida, so it doesn't matter when I charge it. So I choose to charge it when the electricity is cheapest, which is when I'm generating solar electricity and trying not to send it back to the utility. So again, these are flat curves, higher charging rate, but very much faster because it's 240 volts instead of the 110 volts. The top level currently is what are called DCFC, direct current fast chargers. This is not something you want in your garage. We're talking about 480 volts, which you don't have available in your house. You're talking about 100 amperes. So that means you would need a special transformer. So these are only available in public locations, generally near the interstate highways. And they're essential if you're going to do a long trip in an EV, because remember, you can't in the EV switch to gas if you run out of electricity. You have to find a charging station. These are not required for the plug-in hybrids because you can switch fuels. And in fact, few public plug-in hybrids have the high charge rate. In fact, only the Highlander was the only one I found that does allow the Hive charging rate. Now, there's a problem, as there often is. We haven't got compatibility. There are 3 different charger plug types, and somebody in the standards area has to knock some heads together to get this done. My hope is at least you have a conversion cable available. And these are not cheap. And this is part of the problem we're going to confront. They cost $10,000 to $20,000 to put in one of the charging stations. And a charging station at that price can only charge 1 car at a time. If you want to charge 5 cars, you need 5 charging stations. More on this later, of course. Now, my car has some controls. I can set the start time. I set it at 8 o'clock in the morning, or I can set the end time. I have to go to work at 7 o'clock. I actually don't, but somebody might. And you can also pre-air condition at the end time. So if I'm in a hot climate, I am, I could have my car up and ready to go and completely air conditioned. Or you can just say charge it when it gets plugged in. So when you plug it in, power is available, it starts charging. One hopes that if the power goes out, comes back on, it will resume charging. I haven't tested that yet, but I'm just assuming that. Now, let's talk about range anxiety, because this is the problem. It's a real problem because, for example, if I drove to the airport and had to find a charger, I might miss my flight. If I plug it in and the charger doesn't work and my car is empty, I can't go home. I don't want to charge my car on the road because I've got to find a charging station. They're few and far between at the present time. I would be concerned about the charger being available once I get there, or I can see fisticuffs breaking out if it gets really hard. And of course, at mealtime, everybody wants to charge because noon will be the prime charging time because you can go have a leisurely lunch and the car is fully charged. Unfortunately, there's a line of cars at the charger, and it's not a good thing. So this is the essence of the electric vehicle problem. And we have to get between here and there, and that's not obvious. The only solution I can see, and I'll talk more later, is that I can reserve my charger and have it available when I get there, either at the charging station at lunchtime or at the hotel at night. There'll be much more on this as we go along. Other unresolved issues that are still around, the highway tax is a problem because the highways are supported by gasoline taxes. Federal 18.3 cents per gallon, states anywhere from 20 cents to more than 50 cents a gallon. And with an electric vehicle, no gas, no highway tax. Now, this is a plus until you realize that this will not last because we still have to maintain the highways. So somebody's going to pay. And it was rather annoying when early on I learned that some states are charging extra for the license fee for electric vehicles, figuring that's not a very good way of encouraging electric vehicles, but it's something we have to get it taken care of because an electric fleet is not sustainable in the highway tax area. So how that works out remains to be seen. Another thing that concerns me is if I do run out of electricity, what happens? Do I call AAA? And if I call AAA, do they have gasoline? But I can't use gasoline. Do they have a fast charge battery? I don't think they do yet, but maybe they do. Or are they going to call a tow truck and tow me to the nearest charging station? I don't know. I don't know the answers. Another issue with electric vehicles is the longer the range, the heavier the battery. And the heavier the battery, the lower the efficiency. The heavier the vehicle. Now, the handling gets better, but the vehicle is heavier. And so you need more kilowatts per mile to lug that battery around. Now, to give you an idea, the Tesla 85 kilowatt battery weighs 1,200 pounds. That's approximately 6 or 7 normal individuals. So even if there's only one person riding it, you're hauling around the weight of a full car load of relatively heavy people. So that's an issue. Do you really want to drag that weight around going back and forth to the grocery store? Or is another solution more likely? Also, there's perks currently with electric vehicle. Preferred parking. You go to the airport, you may find some electric vehicle stations right near the door. What you'll find, however, is they're all full because people drove in their vehicle, plugged it in, and went away for 3 days, or 4 days, or 5 days. So it's not going to work out more later. Another good perk is access to the high occupancy vehicles lanes. Some states allow that, and it's certainly more attractive than putting a dummy in the passenger seat. But again, not sustainable for an all electric fleet. So, and here's one I just added. The interstate highway was sort of a disaster for downtowns because everybody went around the town and nobody went downtown. Now, does the same thing happen with charging stations? Are charging stations sparse? And I can't go to interesting areas like national parks, which are somewhat far away from the beaten path. So just to raise a concern, there may be a fringe effect here that we haven't thought about. Okay, where are we going to charge it? Well, the best place to charge it is the place I'm using. I just plug it in at home. I've got 10 hours. It's a private garage. Apartments usually have assigned spaces. I can do a level 2 charger, although level 1 is probably enough. Vehicles can program the start and end time if you have time of day pricing, which we don't, but often after midnight, the electricity is cheaper. You can set your car to charge after midnight and get maybe a 25, 30% discount. It's a great location because the car is sitting there all night. You don't need a very high rate of charge to get ready to go for your next day. And the electric usage is just charged to your electric bill, your residential rate, no demand charges, just some more kilowatts. Now, I mentioned demand charge. I better explain it because it's not on electric bills. Commercial electric bills have a charge which is called a demand charge. And that's a strange charge because it's not based on how much energy you use. It's based on the maximum amount you used during any 15-minute interval during the entire month. So you can really get hammered if you plug in 3 high charge electric vehicles simultaneously for a couple hours, and that spoils your electric bill for the entire month. So this is going to be an issue when a number of cars arrive at once to a charging area, whether it be a parking garage, whether it be a restaurant or whatever. So this will be in the back of our minds as we continue on. Another good charging location is work or school, because cars are parked for a long period of time. You don't need a rapid charge if your car is going to be parked 8 hours or 9 hours in the company parking lot. In fact, you could probably get away with a level 1 or level 2A. Probably level 2 would be the preferred mode, but 2A would certainly be sufficient. And you would probably have assigned parking spaces, which means that only one car can be charged each day at each space. However, you might want to go with level 1 on all the spaces because level 1 is enough to charge a vehicle to get you back home, provided you don't live more than 30 or 40 miles away from your work. Strong suggestion that solar panels on parking canopies is a good idea, especially in a snowy climate or a hot climate. It only takes 4 300 watt panels to provide the charging for the car in that space. So it's a good balance. Now, the car has to park all day. We can't do cycling of cars through the lots. We're going to waste more productivity than we would gain in efficiency. Now, there is the demand charge to be worried about, because if everybody arrives at work at the same time and plugs in at the same time, then the demand charge is going to be peak at that 8 o'clock starting time. So perhaps we could cycle the rows of cars at staggered times, as long as we get 4 hours of charging time for each vehicle. That should be pretty much enough to get the employee back home and maybe home and back to work. Now, there's a slight issue here. Is this an employee perk, or does the employer have to charge for this? Not a major issue, can be worked out. Another location we want to do charging is in hotels or any other place where the car is going to be sitting at night, because here's another 10-hour time slice where we can use a relatively low charging rate and still achieve what we need to achieve. Now, here again, we don't want the customer having to get up at midnight and move his car so somebody else can use the charger. So we have to assume that that space is going to be tied up for the entire time. It would be nice to be able to pre-book the charger. However, may not be necessary unless you're trying to do high-speed charging and have reserved high-speed chargers. There might be an extra charge for the charger space, or the charger might be metered. But I think there's a better way. We'll see it later. So it certainly is a sweet spot. There's ample time. Level 2A or 2B chargers would be sufficient, even for EVs, where you might want to put 180 miles worth of charge on the charger. You could still do that with a relatively inexpensive 2A charger. Certainly do it with a 2B charger, which can give you 400 miles overnight. But of course, there's already ample parking spaces, and it does make maximum use of the plug-in hybrid battery, because I can start with a full charge every day on the battery and use the entire battery during the course of the day. Other areas we might park the car for a significant amount of time. A daily commuter lot. The car would be there all day. And if we had level 1 chargers at each slot, the car would be fully charged at the end of the day, assuming a 40 or 50 mile range battery. There are several items of value. First of all, you may have to pay to park there. The value of electricity costs something. Possibly you could use a parking lot or a airport lot to do load balancing for the utility. This is going to take a lot more work to figure that out. So let's pass on that unless we can get some big help from the utility for doing that. So if you're doing that, the customer would have to say when they're coming in, when they're leaving, to make sure the charge is done, how much charge they need. And there's two costs: tying up the space and the cost of electricity. Now, with the plug-in hybrid, of course, this is good because I could then start from the airport with a full charge and head home. My airport is 75 miles from my house. I can't get a PHEV currently that does 75 miles, but I can get 30 or 40 miles. And if I get 30 or 40 miles each way, that's more than half my distance is done on electricity. However, I think there's a better way. And that would be just provide a level 1 outlet in every single parking space in the airport garage. Standard 120 volt outlet. A duplex outlet would handle 2 spaces. It would allow EV and PHEV to plug in for the duration of the stay. And since it's a level 1, the EV is not having a high draw because it's restricted by the amount the circuit can provide. Now, the user would have to provide their own cable, but that's standard equipment. I've got one in the back of my car. I would just have to plug it in. I might want to put a locking hasp just in case somebody wants to steal cables. There is copper in the cables. I think if there's enough of them, that's not going to be a major problem. but needs to be considered. As soon as I get there and plug it in, the charging starts. Now, the airport is good because people arrive at highly staggered times. Some arrive in the morning, some arrive evening, some arrive midday. So the demand charge is not going to be as big a problem for the airports as it would be for a work environment. But the key to this is there is no charge for the electricity. It's a part of your parking fee. I'm paying $20 a night for a 35-mile range, which is what I've got. It's less than $1 worth to charge it fully. And if I had an EV with a 350-mile range, it would cost about $10, but it would require being there 3 days to fill that with a level 1. So here we've got the problem solved because you just drive there, you plug in anywhere, you go away for a day or two, you come back, it's fully charged. And the hotels, of course, can do the same thing. Now, highway chargers are a different animal completely. The requirement is for fast charging because even with a fast charger, it takes 30 minutes for a 100-mile range or 60 minutes for a 200-mile range. So I'm not going to be able to do my 500-mile trip without stopping to charge 1 or 2 or 3 times. It's not clear that the charger is going to be available. Suppose somebody else is there and the charger is full, but they're off eating, and I'm going to get very aggravated at that point. So I'll probably need a penalty fee for leaving it there after it's charged. The mealtime rush on a peak travel day, holiday, is going to be something to behold. Obvious locations are these big areas like Pilots, Flying J, where charging fuel and food, and maybe we need a movie as well if it's going to be too bad. But we do need the ability to reserve the charger for a specific arrival time. Otherwise, it's first come, first served, and I don't like the looks of that. There are areas where people suggest having charging, which are not good ideas. Churches, movie theaters, restaurants, those are very cyclic during the daytime. You go to church, you spend an hour, hour and a half, and you leave. And everybody is coming and leaving at the same time. The demand charge would be through the roof. Movie theaters and restaurants, same problems, not enough time, too cyclic. And you can't afford, I don't think any church or restaurant is going to be able to afford expensive DC chargers. Shopping centers might be a possibility because people spend some time there, but then there's a question of whether shopping centers are still a viable business model. There seems to be some concern that people don't shop at shopping centers anymore. Now here's a reference I found, which I find interesting. Rocky Mountain Institute is a very well-respected electric vehicle and all sorts of climate change options. There is a reference, long word, 1 in 5 cars need to be electric by 2030. What will it take? You can look it up. But it says there, 80% of all charging takes place at the home and 15% of that charging takes place at work. That leaves just 5%. Some of that can be done with level 2B chargers at airports and hotels. So the current panic over the slow pace of DCFC seems to be overblown because the only place you need them are where people are trying to travel hundreds of miles per day, and that's the interstate. So maybe these are more localized than we think. We don't need them everywhere. So let's see what happens. Here's a product development. We've got to have this. We need a charger reservation system for the public chargers. You need a vehicle or phone app software that monitors the car position, monitors the battery charge, locates chargers along the route, presents the driver with charger options, wait time, location, price. The driver selects the option, or the software does. It reserves the charger for time of arrival and amount of charge required, provides payment information and pays the reservation deposit. You better pay a deposit, otherwise you might decide to drive right past and have tied up a reservation that you're not using. And the phone app communicates with the car computer or is the car computer. So that's one side of the software. The other side is the charging station has to participate. It monitors the charger availability and schedule, posts on the internet the information required for the other app. It makes reservations and accepts reservation payments, makes the charger available for a reservation holder. And key point, it has multiple cables per charger, 2 to 4, I suspect, only one active at a time. The reason for this is the car might plug in when it gets there early, no foul, or the guy might linger over lunch and not unplug. Again, there's other cables available. So the more cables, the more flexible. And of course, it bills the credit card or bills the app. With such an application, I could start off, and if it wasn't a holiday, be reasonably sure that I would have readily available chargers at anywhere before my battery runs out. So that, I think, is an essential set of software for the electric vehicle revolution if it occurs. Now, there are a couple other opportunities for level 2 chargers, which I tried to outline, but then I decided it was better just to give everybody free electricity than it was to go through these. So I'll skip those and go on to the government. The government has participated in the electric vehicle, but a very strange thing, they only participate up to 200,000 vehicles, and then they stop participating. And it's not clear to me why you want to incentivize the first new vehicles and not provide incentive to people who are helping to solve the carbon problem. It's a long-term society benefit to have more and more of the fleet convert to electric operation. And the rebates should be for both EVs and PHEVs, perhaps based on the range or whatever. But there also should be a tax credit for charger installation. And there is for individuals, but we want to encourage developers to pre-install level 1, level 2 chargers, especially level 2 chargers. For example, I have a net zero community called Green Key Village. The contractor pre-wires with the wiring, but not the chargers and not the circuit breaker, so that anyone who gets electric vehicle can put in the circuit breaker, plug in their cord, and they're ready to go. So, but a incentive from the government to do that sort of thing would certainly be a way of encouraging it. It's not that expensive to do at the time of new construction. It's a little more tedious to do if you're trying to retrofit it. So that seems to me to be a good idea. Now, what you need for battery, of course, depends upon what you're using. And the important parameter is your typical daily usage. You would like your battery to be big enough to handle your typical daily usage. We'll assume the car can be fully charged at least once a day, normally at night in the home garage, or at a hotel, or at an airport. And we assume also that it may be chargeable, if necessary, at work or at the computer lot. So in other words, the battery needs to be just big enough for what we do most of the time. As I showed you in my original slides, I use my gasoline engine almost not at all because my normal daily travel is 20 to 30 miles. Then my weekend travel is 20 to 30 miles. One of the side effects of being retired is there is no difference between the weekday and the weekend. But what did people actually do? Well, here's a curve of the average miles per day. And then we see it's a peak at about 24, 28, 32 miles. And then it begins to taper off in the 44, 48, 52. So if I take my car at 36 miles charge, I'm well over the peak as far as how many days that I'll be completely sufficient on the electric. Now, if I was a working person and had to go to work every day and could charge at work every day, then I could double these numbers. because I could charge both at home and at work. So what we're looking for are batteries that are in the 40 to 50 miles per day range to handle the bulk of the usage. My point here is that we may have to use a little bit of gasoline in case of emergency, but 80, 90, 95% of our usage can be electric with no pain at all. Or another curve, trip length. Most US car-based trips are short, so except for the few people that go a long ways, that's the blip for the road trippers. And another curve which says the same information. Now, for the plug-in hybrid, the optimum battery size is the size which will cover a full day of travel on most days. Usually the work days, although some people travel more on weekends and work days, but typically the work day is the longest mileage day. So if you look at the previous one, you have to, I apologize for my greyhounds. Greyhounds don't bark, but this greyhound does. So my wife is coming in. He'll calm down in a moment. So anyway, the basic battery size, 80-mile range. If we had a 15 kilowatt battery, the battery price would be about $1,500. That's with a goal price of $100 per kilowatt hour. Currently, the price seems to be about $137 per kilowatt hour. Now, that's a big commute. If you're at 80 miles, that's 2 hours of commuting a day, and nobody in their right mind is going to do that amount of commuting. However, also 80 miles is not yet available. We're pushing 50 miles, and those of us in engineering know that if you're only a factor of 2 away from your goal, you're almost there. If the charges available work, of course, the 40-mile battery is sufficient. And we don't require the high voltage or PHEV. So the whole stress over where we're going to get enough charging station is completely irrelevant to me. I have a PHEV. I'm going to keep it 8 to 10 years. And by that time, there won't be a problem remaining, I hope. Now, if you're going to get an EV, the optimum battery size is the size that will cover all but your longest trip distance. And that's round trip, because if you go somewhere and you require a charge, you're going to have to find a hotel with a charger, or you're going to have to find a on-the-route charger. So if we look at the previous distribution, it would appear that the best size for EVs is about 250 miles. Now, that's not unreasonable because many of them, and I'll show a list later, have at least that range. So the battery size of that is at least 50 kilowatt hours, and the battery price of the battery itself is about $5,000. You've got a heavier car, less mileage. You should have a larger battery yet if you're doing frequent trips. You still got your range anxiety, and a 500-mile day would require midday and evening charging, and I really don't want to do that. Okay, so what have we got available? Well, here's our PHEV chart as of 2020. This is from US News and World Report. If we look down through here, notice the price is not that much different than for gas vehicles. These are generally smaller vehicles, but still the price range, I see a 26.5 and I see a 39.9. Electric ranges, notice my Toyota Prius Prime is rated at 25. I'm getting 36. I don't know what the variability in these other numbers are, but you see the numbers are almost 50-mile range. The gas mileage, also notice why I got the Toyota, 54 miles per gallon is the rated gas mileage. But notice 40 and 50 is not unusual for the gas mileage for those times when we have to go to the gas engine. So this is the current set. My wife is looking at a Subaru Crosstrek as her next one. I'm not sure about the electric range though, so we're still discussing that. Moving on to the available EVs, Yeah, here now we can spend some real money. Notice the Tesla Model S at 75,000, Tesla Model 3, the hot seller, at 38,000, not bad at all. Tesla Model Y, 50,000. And then we've got the Porsche, for those of you into that sort of thing, at $103,000. Let's go on to the range column. Notice the Tesla Model S 402. That's the top of the list. And way down at the bottom is the BMW at 153 miles. But there's a variety out there for anybody who has a particular favorite supplier. There's the Chevy Bolt, 259 mile battery. Notice 250 is sort of a reasonable number in this column of numbers. So my recommendation is that we ought to be more focused on the PHEV, the plug-in hybrid, for the current sales. We'd like to get 40 to 80 mile range. We're not there yet. We're well above 40 available, but we're not at 80. But it is still less than a factor of 2 over the current range. Level 2B is as high as we have to go with the charging. We don't require any of these expensive, hard to find charging stations. I expect to keep my car the typical 8 years. So that gets me to 2030. I estimate on these vehicles, for the normal way of using them, 80 to 90% of the travel will be electric. You saw that I'm getting 400 miles per gallon. That's half non-COVID and half COVID. So there is some bias to it. There's absolutely no range anxiety. The only range anxiety I have is my user manual says I have to use a new tank of gas every year. And last year was a little bit of a struggle to get enough gas used so I could put another tank full of gas in. There's no panic whatsoever over charging station. Only long distance drivers with the large batteries will or can use the charging station. And the efficiency is higher because we're not moving that heavy battery pack for every single short trip we do. Now, the next generation, when we get through the 10 years of the PHEV, will be EV, because by that time we'll have 500 mile range batteries. We'll have lighter batteries, and we should have a mature network because enough people will have gone that way to start building up the network. At that time, 100% of the travel would be electric on those vehicles that have gone to electric. And the trend and the push is toward an all-electric fleet, but that it's to be done by 2050. And by doing a two-step as opposed to one step, I think we have a chance of doing that. However, this is only a small part of the story. The grid itself becomes an issue because it's not clear if everybody plugs in at night, whether the night capacity is there, or if we go with a lot of solar on the grid, maybe daytime charging would be better to use the surplus solar energy, in which case work parking would be a very beneficial to the grid because it would pull off the electric from solar or from the solar panels right above the car and not affect the grid at all. Now, to balance the grid, the utilities may need batteries themselves. So now we're doubling the battery requirement because we're not only storing electricity in our car batteries, we're also supplying electricity in the utility batteries to charge the car batteries. However, the bright side of that is the utility batteries don't have to be lithium ion, and lithium ion may be a critical point in this whole transition. Non-sun dependent sources may become more valuable. Hydropower, Pitt is putting in their own hydropower plant, as you may be aware. Nuclear power, which is a steady baseload power, or geothermal, which is a possible upcomer. Now, as an appendix, and is available, I put together a worksheet where you put in your car specs, you put in your workday information, you put in any special trips you're doing, and you get a result of total miles, electric costs, and gas costs. And it might be fun to play with this as you're looking at whether an electric vehicle makes sense for you. And if so, plug-in versus all electric, certainly something worth thinking about. So with that, I've gone through my slides. You're welcome to get copies of those slides. I'm going to turn it back to the host and see if we can do any question or discussion. Thank you very much for your attention.
Thank you, John. We have several questions. I believe Kate has been documenting them. So maybe the best way to handle that would be for Kate to throw them out and we'll generate discussion that way.
Fine with me.
Okay, Kate, go for it. Thank you.
Excellent. Yeah, I've been writing them down throughout. Some of these may have been addressed, but I'm going to try to pull out the ones that haven't. Well, how do EVs compare to hydrogen vehicles? You touched on that very briefly, that's another option.
Okay, my position on that is basically we have a electric network. We don't have a hydrogen network. So I see the hydrogen as a possibility, but not a strong possibility, just because of the network issue. Now, if you have a fleet, hydrogen makes sense because then you have just one charging station where the fleet sleeps at night, and it could make sense. So I think there's a niche, just as there is for biodiesel, for example. But I think the main thrust will be to the home charging electric vehicle.
Great, thank you. And then we have a couple of questions in the chat right now about battery issues. One is, are there any issues for battery life with partial charging each time? And then it's a separate question from someone, but how are batteries disposed of once the life cycle is done? And is there pollution issue with the battery manufacturing?
Okay, there's actually several questions there. One is batteries are recyclable. In fact, if lithium gets scarce, we certainly need to recycle them because we need to get the lithium back. Currently in California, there's some problem of battery theft. People are stealing batteries because they're using them for their own cars or for their own experiments with power storage. So I think that with the electric vehicles, it's strongly stated in the manuals that do not dispose of the battery yourself, bring it back to the dealer. So the collection of batteries for the recycle chain is already in place. As far as partial charging, I don't know an answer to that because I just plug mine in full charge every day. In my hybrid, it was set at 50%. The battery operated 50%. So when I went downhill, it went above 50%. And when I went uphill, it drew from that charge. And they say the battery lasted my 9 years with no issue. So I don't think there's a big issue. Now, if you're going to try to use the batteries as a resource for the grid, I don't think so. What you can do, however, is schedule your charging. So you reduce the impact on the grid. For example, charging at night when the grid is more available, or conversely, charging in the middle of the day when the solar is available. But don't try to go backwards. Don't try to discharge the battery into the grid. Just adjust when you charge the battery. I think we'll be all right.
Excellent. Excellent. Well, the questions are coming fast and furious, so I'm just going to pick them out that are, that seem a little bit different. Do you have any thoughts on electric flight?
Electric what?
Flight.
No.
Okay. Okay.
Yeah, that's a battery weight issue. And maybe for short flights, people are looking at it. I'm not.
Okay. That's great. Can you talk about heating the passenger compartment?
No, because I'm in Florida. So I've not yet come to, yeah, I know all about the air conditioning. I know how that works, but I haven't a clue as how the heating works. Now, bear in mind, I do have a gasoline engine in here. So I presume they could actually start the engine to warm the car up in the morning. But if I've got it plugged in at preconditions, so it's warm enough if I schedule that using my house current. Not a complete answer because my experiment has not run up into Pittsburgh yet.
Great. Can you talk about one of the questions says, what happens if involved in an accident, electric vehicle versus gas vehicle in terms of death risk due to batteries?
Somehow I feel a little more secure with electric battery than with a big tank of gasoline back there. So I think the protection for the fuel source is probably quite the same problem. You don't want anybody smashing the fuel source up, whether it's gasoline or whether it's batteries. So I think that's sort of a wash, but that's my opinion.
Mm-hmm. Great. And do you think batteries and solar panels will advance far enough that we could see completely self-sufficient EVs in the sense that panels mounted to the vehicle could provide all charging needs?
Well, now we'll go back to panels. Panels basically work best if you're still connected to the grid. In other words, when you have excess, you put into the grid. When you have a need, you take from the grid. I don't think that changes at all if you plug in your electric vehicle. The only thing I'm doing is plugging my electric vehicle into charge when my panels are generating, because I'd rather use electricity at 9.5 cents than send it to the grid and then buy it back at 12.5 cents. So I'm getting some benefit from my panels, but it's not any major change. To disconnect and just say, I'll use my panels to charge my car and not charge if the panels aren't running, I think is worse than having charging stations along the interstate as far as aggravation and stress. So I don't recommend that. I still would go with the grid.
Great. Dr. Swenson, I'm wondering if you can speak to some fundamental changes in mobility.
Okay, but I'm not sure where I go with that. There is the issue of whether or not we're going to be doing as much moving around post-COVID as we did pre-COVID. I don't think that's answered yet. I do have a committee I work on, which has decided that we're going to Zoom forever, because why would we spend 20 or 30 minutes going to a meeting place when we can do just as well with a 6-person committee by sitting at home and not going anywhere? So there may be a significant effect, not due to electric vehicles, but just due to having perceived a new reality that we may not go right back to the same reality. So that's a different issue than electric vehicles, but it's just my comments on the subject.
Yes, absolutely. That makes a lot of sense. One question that sort of goes along with that a little bit is, do you think that part of the solution is through on-demand electric vehicle car rental? Can the transportation problem be segmented into local commuting versus highway travel?
Yeah, a lot of people don't have cars and rent car, like in New York City, for example. They just rent a car whenever they're going to go somewhere long. So that already is a viable model in some areas. Other families like mine have one electric vehicle and one gas vehicle. And for two reasons. One is my wife likes to drive and likes to drive her car. So we use a gas vehicle for long trips. But also, if we had an all electric vehicle, we would still have the option of using the gas vehicle for the longer trip, which sort of defeats the purpose of the electric vehicle. So there are a lot of mixed models that one can conceive of and will certainly develop. But the end goal should be to do as much electric as possible and as little gas as possible. But I don't think we have to immediately mandate there will be no gas. If I can get away with 90% electric and 10% gas and not worry at all, I'm going to go that way.
Mm-hmm. Great. Let's see, a few more questions. Where do you see electric vehicles taking off beyond cars? Buses, trains, motorcycles, trucks, etc.
Well, I mentioned the depot effect. Buses, for example, go home at night and you can charge them. I'm not sure what the range of a bus is. Charging during the daytime for a revenue producing source is probably not the best of ideas. However, many bus routes are heavy in the morning, heavy in the evening, and not as heavy midday. So maybe you could get a midday charge there. So I think that's going to sort out with delivery vehicles, buses, trucks, in different ways, depending upon exactly how they're used, because they're generally used the same way every day, or at least every weekday. And there are different strategies. For example, buses could park in the garage all night at a fairly high level 2B charger, and maybe come in at lunchtime for another update. But I've already addressed passenger vehicles, in particular my passenger vehicle need. There are all sorts of things involved in all the other transit options that would be the subject of the whole course, as opposed to one lecture.
Absolutely. Another question, it talks about what danger does the high DC voltage pose to the owner and the repair mechanic?
Well, the repair mechanic is trained, and as an owner, I've never been inside any of my vehicles for the last 20 years. I don't have a clue as what goes on in there. Well, I know what goes on in there, but I don't know where it goes on. And I would not risk, other than putting some fluid in if I had to, I would not go in there. So I don't think there are that many people now who do servicing on their own vehicles. They've become much too complex. So I think anybody who's doing that probably is smart enough to know they don't want to screw around with the high voltage battery terminals. But I haven't heard of any problems occurring, and that's my explanation of why I haven't heard it.
You have not met my husband, apparently, because I.
Do you have an electric vehicle that he's poking around in?
No. But I can.
If so, check your insurance policy.
Yes, absolutely. Another question is, approximately what percentage of cars is pure EV at this time?
Less than 2%. The early slide I showed from MIT said less than 2%.
Great. I'm sure that I've skipped over some questions. I'm trying to scroll back up through. Please feel free to keep them coming in. And now we have some. How do you see this affecting the trucking industry?
I don't. I've not studied the trucking industry. The trucking industry and rail industry, I think rail is more likely to go electric sooner than trucks, because rail already has the infrastructure. In some areas, they have overhead wires. Other areas, they have charging stations. They're looking at separate vehicles that attach to the engine, which contain the batteries. And those can be swapped in and out fairly quickly. Remember, back in the early days of electric vehicles, there was thought of, we'll change the batteries instead of charging the batteries. That didn't work out. Nobody's thinking about doing that anymore. But with a train locomotive, with an extra battery charge car, you can just couple up to a new charge and go off again. Railroads also do a lot of recharging when they're going downhill, cycling back the energy. Trucks are a little more, they're going to take really big batteries. And depending upon how battery prices go, bear in mind a vehicle with batteries and an electric motor is a lot simpler vehicle than a gasoline powered vehicle. Electric vehicles have a very high torque at startup. That's hard to do with a gasoline engine. And their service is much lower. There's not very many moving parts. So there are a lot of advantages to electricity. The only downside, of course, is the batteries and the charging thereof.
Great, thank you. Another question we have here, does the technology used to generate the electricity, for example, coal versus nuclear, make a substantial difference in the amount of carbon offset by going from gas to electric vehicles?
Yes. Clearly, we don't want to use coal plants to drive our electric vehicles. But they're separable problems. We want to get rid of the carbon emitting in the utility sector, but we want to have enough energy at the proper times to charge our vehicles. Now, the vehicle load is only about 20% of the total energy load. So it's not like we're doubling it, but it is a significant change. But there's a lot of excess in the energy now. It's just at the wrong time. and vehicles have the opportunity to do time shifting, like use nighttime resource for the energy demand during the daytime. So there's some opportunities there as well as possible problems. But we don't want to burn coal for anything if we're trying to reduce the amount of carbon.
Absolutely. So another question, with increasing demand and projections of mined lithium shortages, which is more likely, recycling battery materials keeping up with the demand or development of new non-lithium materials?
A lot of this is all of the above. For example, if I'm talking about PHEVs, I'm talking about much smaller batteries. If I'm talking about say a 50-mile battery for a PHEV or a 400-mile battery for an EV, I could do 8 PHEVs for the lithium in one EV. So one downside of the big batteries in the EV is it's not a very efficient use of the resource. A lot of it is not used except for those occasional long trips. Recycling is, you got to recycle both because of the lithium, but also because you got to recycle batteries. You can't throw batteries in the trash. We recycle lead batteries now. Anytime you change a battery, you get hit with a charge for recycling because they're required to recycle. So I think the same thing occurs with lithium. Price will determine whether we're going to recycle them. But I think also we'll recycle them because we've got to get rid of them. Now, some lithium batteries are actually being recycled into home storage. Tesla, of course, is offering home storage batteries, but used automotive batteries could also be repurposed into home storage. And that would be a doubling of the market size because it would take as many batteries as there are in cars to do the home charging. So I don't think there's any recycling problem because I think there's going to be enough demand for lithium. Now, bear in mind that the utility storage doesn't have to be lithium. With cars, the weight of the battery is important. With utilities, the batteries sit on concrete pads out in the grid support, and it doesn't matter how much they weigh as long as they're cheap and can store a lot of energy.
Great. Well, we still
another whole subject for a course, energy storage.
Great. Another question, utility companies like Xcel Energy are developing public charging infrastructure in Colorado. What are the roadblocks for other utilities companies seeking those opportunities?
Well, I've been lecturing to utility companies for quite some time. First of all, pointing out that solar energy is energy and they ought to be all over it. Also pointing out that it wouldn't be great to screw the gas and oil companies by taking over the automotive fleet, enlarging your market and diversifying your market. So I think utilities should be all over this at this point, whether it's charging stations or flexible ways of providing electricity for car charging. I think there's a lot of opportunities for utilities to think about this in constructive ways because it's going to add 20% to their market. They ought to be able to encourage that and make money at it.
Great. Moving down the list, we have a question about, it says nuclear energy as contained energy source in a car is an old idea that was scrapped. Is it being reconsidered?
Nuclear energy in the car? Mm-hmm. I don't think I'm in favor of that. I think getting rear-ended with a gas tank is bad enough. Getting rear-ended with a nuclear reactor, I don't think I want to be there or anywhere near there. So I can see why it has died, and I wish it well. I would like the small modular reactor buried at the site of the coal, shut down coal facility as a much more viable approach to nuclear.
Great. And can you tell us if you have any thoughts on switching out a full battery for an empty battery versus charging? That
was an original idea. I think Israel looked at some stations to do that. It sounds like a good idea, but it's not cheap, and you've got all sorts of different vehicles. So the whole compatibility issue, I'm sure, is there. I haven't heard it mentioned recently as still being something being considered. Someone will think of it, but I think it's gotten out of control with the number of different electric vehicle designs out there. I think if you had just one brand of Tesla, you might consider that. But if you've got 20 or 30 different vehicles, all with different topologies and all with different batteries, I think that horse is gone.
Great. Can you tell us, in your opinion, is the core of the issue more with the government, the buyer, or the automaker?
I think the core issue is range anxiety. As I showed in that first slide from MIT, people just don't want the hassle. So if we can make it hassleless, and possibly cheaper, because my energy costs are very low for my car at 400 plus miles per gallon, equivalent miles per gallon. And it doesn't behave any differently than what I'm used to. I think that's a much easier sell than all the stuff that's going on around the electric vehicles. Hence why I'm recommending the plug-in hybrids as the current path for anybody interested in doing this. Start there and then wait 10 years and see what the EVs look like, because you're going to get another car in 5 or 10 years anyway. Just don't rush into a EV when you can get a PHEV and get 90% of the benefit with none of the hassle.
Great.
Just my opinion.
Thank you. Another question here. Have any companies utilized rotational energy from the tires to take care of electric needs, AC and heater lights, to minimize the battery energy being used?
Well, the energy is coming from somewhere. So if the wheels are going around, the batteries are being used. I've also often seen humorous cartoons where somebody's dragging a generator behind them on a bicycle wheel to generate the energy to run the car. And perpetual motion has been a dream for a long time, but I don't think we're any closer now to perpetual motion than we've ever been. So I can see using some heat source to heat the car, but I'm not sure the tires are it. And I'm not sure smoking in the car is a good idea either. So I'm not sure where we go with that issue, but I don't think there's any magic bullets there.
Great. We have time for a couple more if you're okay with that, when we do have more in the chat. The next question is, do hybrid vehicles have both a lead battery and lithium battery?
Yes. The utility system is a standard battery, not the lithium ion battery. So you can run out of battery either of two ways, but you rarely run out of your standard accessory battery. It could happen, and it's the same pretty much accessory system. You're not running your computers off the lithium ion battery. You're running them off a standard battery.
Great. Next we have, are there any significant studies that show the total CO2 reductions for the cradle to grave of an electric vehicle versus a gas vehicle, taking into account more than just electric versus gas?
Yes, but I'm not able to quote them. Bear in mind, an electric vehicle is just electric motors, and they're fairly compact and fairly cheap. But there's research. I think a Google search might be able to track down some fairly learned reports. I'm not aware. I'm not pursuing them.
Great. Well, we a couple of other questions. Let me also just say to everyone, if I've missed your question, feel free to add it back in. We have a few more minutes. And if I did miss your question, you can blame it on one of the other 20 Kate boxes on this call. It was obviously their fault and not mine. Okay, so one of the last questions we have in the chat right now is, what is the current efficiency of solar panels and what is their useful lifetime?
Current panels are about 20% efficient. And the useful lifetime, nobody knows. There've been none around yet. Typically, quotes have been 20 to 25 years. I've had mine about 15 years now, and they drop in current capability with time. but less than what was projected. Typically, it was 10% in 10 years. And mine seems to be holding. The more usual problem is they get dirty. I just recently took mine off, took them down, cleaned them, put a new roof on, and put the panels back on. So mine are clean for the first time in 2 or 3 years.
Great. And can you tell us what your thoughts are on autonomous vehicles?
You'll peel my steering wheel away from my dead hands. No, I'm not going there. I don't trust them. I enjoy driving. I don't want to lose that. It's a chance, driving actually is a chance to actually interact with others, to have the feeling that you're doing something cooperatively. Now, it doesn't always work that way, but it can. When you yield right of way, somebody nods to you and so on. I think we'll lose that, and I just don't trust computers that much. People do strange things, and I'm not sure computers will ever accommodate all the strangeness that goes on, like cats appearing in the screen and so on.
That's great. Another question involves how will PHEVs and EVs be made available for those in cities with only street parking?
Well, I'm not sure in a city you want a vehicle. The previous was mentioned, the ability to get a vehicle on demand. And I don't think you want to depend upon street parking in a city. That doesn't sound, that sounds as stressful as anything else we can talk about. But if you had street parking, but you had charging at your workplace, you probably could use the workplace charging rather than street charging. But generally, my assumption is if you have a car, you have a sheltered place to park it, and you could probably get a power outlet to that place. So street parking, I don't think has its problems of its own, independent of electric vehicles.
Great. And we'll do one last question I have here, and then thank you so much for your time. But the last question we have here is, taking into consideration the cost to produce batteries and electric cars, how does it compare to the pollution based on the charging and all of the other costs that are involved with electric versus gas vehicles, including the disposal of the lithium batteries, which we talked about a bit?
Well, I think if we look at the prices, without government support, I paid $32,000 for my $32,000 and change for my car. I think I paid $29,000 for the Ford Fusion. So it was not that much different. We're on the declining price curve for electric vehicles, where the gasoline vehicles, they've been around long enough. We've rung out pretty much all there is to wring out, and expecting a 10 or 20% drop in manufacturing costs for gasoline vehicles, I think would be optimistic. A 10 or 20% drop for electric vehicles, I think is very realistic. There's the equivalent of Moore's laws for manufacturing that says every doubling of volume gets a 20% reduction in price. And we're a long ways from running out of volume doubling for electric vehicles. So I think there's lots of potential there. Just like with solar panels started at $100 a watt, and now they're 40 cents a watt, and they're cheaper than anything else for generating electricity. I'm not sure electric vehicles will go that far, but we're still on that part of the curve.
Great, thank you. I think we're just at about time. We were scheduled to wrap at about 2:45. You've done a fantastic job answering endless questions and your presentation. So we really thank you. It's been a wonderful event.
Well, I enjoyed it as well. I appreciate everybody being here, and thanks for the questions.
Thank you. Bye, everyone. Thanks all for joining us. Thank you, Dr. Swanson.